All right, guys, everybody has a note sheet, yes? Note sheet, need a note sheet. What we're starting today is chapter 2. So we're starting chapter 2 today. Now, the nice thing about chapter 2, unlike chapter 1, it's going to stick on one topic. We're going to only be talking about quadratic functions. Really, chapters 2 and 3 are going to be covering quadratic functions. Now, the first thing we're going to talk about with quadratic functions is transformations. So we're going to hit transformations again. We've done these before. And when we talk about transformations from the parent function, f of x equals x squared, a, h, and k all have something that is being applied to it that is causing us to change the function and how it looks. If there's something in place of A did one of two things. It was either a reflection across the x-axis or a vertical stretch or shrink. That's really what A did. H, inside those parentheses, move the function to the left or right. If H is positive, it moves it to the right. If H is negative, it moves it to the left. K is our up or down. If K is positive, it's going to move the function up. If K is negative, it's going to move the function down. Now, specifically, I plug in a value for B in front of this X inside the parentheses, and that's where we start talking about our horizontal stretch or shrink or reflection across the y-axis. Now, the first two transformations that we're really going to look at first are horizontal translation and vertical translation. Horizontal, we move to the left or right. If H is positive, we move to the right. If H is negative, we move to the left. And we talked about this before when we looked at the function. If we had x plus 3 inside the parentheses, opposite of what we think is going to move to the left. X minus 3, opposite of what we think is going to move to the right. For our H and K. So I'm going to rewrite this over here. G of x equals x plus 4 squared minus 1. Yes. All right, guys, let's focus in. All right, guys, focus. So I'm going to put the general form. We're going to have A, B, H, and K. For the most part, we've only really looked at with horizontal stretch and horizontal translation, our left, right, up, down. Because if we look at this compared to the general form, do we have a number in place of A besides 1? No. So there is no vertical stretch or shrink. There is no reflection across the x-axis because we don't have a value for A other than 1. Inside this parenthesis in front of the x, do we have a number there besides 1 for B? Well, no. So there is no horizontal stretch or shrink. There is no reflection across the y-axis. Do we have a value for K? Yes. Because there is a number in place of K. It is 1. Would that 1 be positive or negative? It is negative because we have minus 1. So it is indeed negative 1. Up and down is exactly what it looks like. Minus 1. Do we have a number in place of H? 4. Now the question is the 4, this value of H, going to be positive 4 or negative 4? It is. All right, guys. Because look at the general form. It's bx minus h, x minus h, yes? So for us to match it up with the general form, really what we're saying here is is that we have x minus negative 4. Because the only way that we can turn it from x minus h to x plus 4 is if that value of h is negative, because a negative and a negative make a positive. So the x plus 4 for us here is really x minus negative 4. That is where we get that opposite of what we think because of that x plus 4. So the movement left or right, that value of h is negative 4. Since it's negative, it's telling us it's moving to the left 4. And k is up or down. So since k is negative 1, it's going down 1. So the transformation for this here is going to be left 4 and down 1. So when we look at left and right, because it's x minus h, because x minus h is the general form. Because we don't so much care about the b at this point. X minus h is the general form for our left and right. Or do we have x minus a number here? No, it's x plus 4. We need that x minus 4 to see what the true value of h is. And the only way that this is going to go to plus is if that value of h is negative. Questions? Now, if we looked at the graph of this here, because this here and what you have in your note sheet is the parent function. So we said that the transformation that we applied to x squared that gave us x plus 4 squared minus 1 is that we took this function and moved it left 4 and down 1, which means every point on this function would move 1, 2, 4 to the left and down 1. So this here would be our new function. So we could take the point 0, 0, and move it left 4, down 1. Or all those points are going to move left 4 and then down 1. Now for this here, and especially on the homework, I'm not going to ask you to graph them. It's just good to know how this is moving, how this is changing from one to the other. One of the biggest things is because when we start solving, we're looking for where it crosses the x-axis. Because the values of x that make the function be 0 are the solutions for this here. We're looking for the values of x that make the function 0. So if we know how this moves, we know what kind of solutions we should have, where it should be crossing the x-axis. Let's look at the next one. Let's look at this next one here. So g of x equals x minus 3 squared, and that's it. So looking at this here, do we have a value in place of k? No, we don't have anything being added onto the end, which tells us it's not moving up or down. Do we have a value in place of a? No. So there's not going to be a vertical stretch or shrink or a reflection across the y-axis or x-axis. Because that's what a would tell us. Is there a number where b is in front of that x, but after that parentheses? No. So there is no horizontal stretch or shrink. There is no reflection across the y-axis. Well, the only thing we have in place of a term, a value, is h. Yes? Now the number that's in h's spot is 3. So that is telling us we're going to either move 3 units to the right or 3 units to the left. Is that 3 positive or negative? It is positive. Because what's the general form? X minus h, yes? The x's line up. Do the signs match up? Are they both minus, yes? So h is just 3, positive 3. Because since the signs line up, we're just taking that value of h out. It's just 3. Because the last one, we had x minus negative 4. The negative 4 is our h value. Here, the positive 3 is our h value because the negative, that minus sign, matches up to the general form. Because the x minus matches up to the general form, so h has to be positive 3. So that tells us that this function is moving right 3. Questions on this here? So, let's look at this next one here. So, do we have a value for A or B? No. But we do have a value for H and K. K is a little bit nicer. K is exactly what it looks like. Because we have what in place of K? Negative 2. Since it is minus 2, the K value is indeed negative 2. That works kind of nice. H. The number in H's spot is 2. But the question is it going to be positive 2 or negative 2? Positive, because x minus 2, x minus h, those are lining up. So h is indeed positive 2. And now that we have this, we can describe the transformation. Our h value of 2 tells us we're moving 2 units to the right, or we can say right 2. And k tells us up or down, and that would be down 2. So that means every point on this function would move right 2 and down 2. Right 2 and down 2. So if we were to solve this, we see that it does cross the x-axis in 2 places. So we would have 2 solutions. They may not be nice solutions, but we would have 2 solutions. And when I say nice, I mean rational solutions, rational answers. Questions on this so far? We ready for the next one? Well, as we've had most of this so far, A and B don't have a value other than 1. The fact that they're 1 doesn't tell us anything. We do have value for H and K. The value for K in this case is 1. Positive 1 or negative 1? Positive, plus 1. K is nice. H, 5, and it would be negative. Because in a general, or the equation they gave us was x plus 5. In the general form, we have x minus h. So to really see that value of h, we've got to take that plus apart. Because the only way that we can go from x minus h to x plus 5 is if that value of h is negative. Because a negative and negative make that positive. So that value of h is indeed negative 5. So that negative 5 tells us we are moving 5 units to the left. So we can say left 5 and up 1. Because I'm specifying this A, H, and K so that we can start kind of really connecting with that transformation left, right, up, down. Questions on this here? So looking at this here, x minus 1 squared plus 2. Here we have a value of h and k. Our value of k is positive 2, yes? Thank you. Our value of h would be what? 1. Would it be positive 1 or negative 1? Positive, because our x minus h. The x's line up, our minuses line up, so h has to be positive. Now that tells us our transformation is right 1 and up 2. Right 1, up 2. So this right here would be our new function after this transformation, yes? And now that we kind of have this picture of it, where does it cross the x-axis? Does it cross the x-axis? So for this here, if we're trying to find the solution where it crosses the x-axis, it doesn't. There are no real solutions, no real values of x that would make this function equal 0. But that's it. All we would be doing is the right 1 and up 2. So the nice thing with these transformation and knowing them is it gives us a picture of what we should expect. How we should expect the function to look. Okay. We're ready for the next piece. Reflection in the x-axis. So if there's a negative in front of the parentheses, or a negative in front of the x squared outside of the parentheses, that's in our A spot. If that A value is negative, specifically the negative, it's a reflection in the x-axis. So the negative for the y-axis is what I put in place of B. I call it B because I think we need something to differentiate between the two. If it's in front of x inside the parentheses, it's a reflection across the y-axis. Now the x squared, our quadratic function, it doesn't tell us a whole lot because quadratics are what we call an even function. And it's going to reflect onto itself. Negative x squared and x squared. This negative x squared and x squared actually are the same function. But it's reflected across the y-axis, it reflects onto itself. But we'll leave it as negative x squared. We'll look at vertical stretch first. A, if A is greater than 1, it's a vertical stretch. It increases faster along the y-axis. If A is between 0 and 1, it's a vertical shrink. We're not looking at the sign, specifically that value of A. If the A is greater than 1, it's a vertical stretch. If A is between 0 and 1, it's a vertical shrink. Now, and we've talked about those, we've really talked about both of these. Horizontal. When it's talking about this value of A here, it's talking about the value in the function itself. When we look at the equation, that value is what we're looking at. So if it tells us we have 1/4 x, that 1/4 is the value it's talking about here. This here is the value A. And what it calls A, I call B, it's looking at. If that value is between 0 and 1, it's a horizontal stretch. If it's greater than 1, it's a shrink. But when we talk about it and describe it, we've got to flip it. So we would really flip this from 1/4 to 4, which does more line up with our vertical stretch or shrink, how we talk about it, because it's now bigger than 1, it would be a stretch. It's again horizontal stretch and shrink, it's that flip. That flip as we talk about it here. I think it's easier, or I think it's better for us to understand. Just flip it and look at the reciprocal value for horizontal stretch and shrink than to try to think of it in terms of the value they give us, compare it to the stretch or shrink, then flip it as we write it. I think it's easier just let's flip it and then look at it from there. And we'll talk about that here in a second. We'll get to it. So let's look at this here. Negative 1/2 x squared. Is there a value in place of h? No, we don't have anything added or subtracted inside the parentheses. So we don't have a value for h. As we're inside the parentheses, do we have a value in place of b? Do we have parentheses? For g of x, we have negative 1/2 x squared, yes? Is there parentheses in g of x? No. If there's not parentheses, there is no b of x. There's no b. There is no h, there is no b, because they have to be inside parentheses. They have to have those parentheses around it. There is no b, there is no h. Is there a k? No, there's nothing added or subtracted onto the end. All we have is a value in place of a. And that a value is negative 1/2, yes? How many transformations do we have here? We have 2, because we have the 1/2 and we have the negative. The negative, specifically the negative, this here is telling us that we have a reflection across the x-axis. That negative is specifically telling us there's a reflection. It doesn't tell us anything else. The negative is the reflection. That is one of our 2 transformations. The other is the 1/2. Because A is one of 2 transformations. It's either a reflection or a vertical stretch or shrink. Now, because we do have a 1/2, it is going to be a vertical stretch or a vertical shrink. It's a vertical stretch if A is greater than 1. It's a vertical shrink if it's between 0 and 1. So we're not looking at the 1/2 or negative 1/2. We're just looking at the 1/2. Is 1/2 bigger than 1 or between 0 and 1? It's between 0 and 1, which tells us we have a vertical shrink of 1/2. And that's it. The negative told us we had a reflection. The 1/2 told us we had a vertical shrink of 1/2.
So negative is out of the number that would be a reflection.
The negative in a spot is a reflection. That's all it's telling us. The number tells us the stretch or shrink. Are you ready for the next one?
Yep.
Looking at this one here, do we have a value in place of A? No. So there is no horizontal or vertical stretch or shrink. There is no reflection across the x-axis. Is there a value in place of H? No, which means that it's not going to move to the left or to the right, because we would need a value for H to move left or right. Is there a value in place of B? Yes. And it is 2, yes? But it is horizontal stretch or shrink. That 2 tells us that there is a horizontal stretch or shrink. Now, the first thing I would do is flip it, give it the reciprocal. Since it told us it's 2, its flip, its reciprocal would be 1/2. If its reciprocal is between 0 and 1, it's a shrink. If it's greater than 1, it's a stretch. So 1/2 is between 0 and 1. So this here would be a shrink. So we would say that this is a horizontal shrink of 1/2. Okay. Before we finish up, is there a value in place of K? K is 1. And it would tell us we would move up 1. Questions on this here? So again, I would advise going on looking, seeing what the value B is, flip it. Let's look at it as 1/2. Because as it's stated in the general form of what we have, it said that it's a horizontal shrink if A is greater than 1. Our A value here is 2, so it would be a horizontal shrink. Then when we describe it, we have to flip it. Might as well flip it to begin with and look at it in that form. Let's look at this next one here. Negative 3x squared. Is there a value of h for this here? No. Is there a value for k? No, we don't have parentheses. So that also means we don't have a value for b. The only thing we have is a is negative 3. We have 2 transformations. We have the negative and we have the 3. The negative, yes, indeed. The negative would be a reflection across the x-axis. And the 3 would be a vertical stretch of 3. With our vertical stretch or shrink, horizontal stretch or shrink, we do have to put the amount that we stretch or shrunk the function by. Questions on this here? Be ready for the next one. Do we have a value for A? No. Do we have a value for H? Do we have a value for K? And it is negative 2. Do we have a value for B? It is 1/4. So before we start looking at how it's going to work, we're going to want to switch it to 4. So the 4 tells us that we have a horizontal stretch of 4 and down 2. Our minus 2 for K tells us it's moving down 2. Questions on this here? Is how this is going to look if we looked at this here. The down 2, so our original point was at 0, 0. It's now going to be at 0, negative 2. We moved it down 2. Yes? Now from here, if we looked at points, our next nice point on the parent function is the point 1, 1. We went over 1 and up 1. Yes? Now, for us to do the same thing, horizontal stretch of 4 means I'm going to have to go over 4 for that 1. So the new point is actually at 4, 1. Because normally we can go over 1, up 1. It's now stretched it over 4. We got to go 4. It's making it stretch horizontally, left and right. Because we said it stretched horizontally, that means along the x-axis is going to increase faster. The next point on this is actually going to be out there. But that's not as important. We got 2 left. I believe it's this one and the next one. This one here. Well, the only thing we have a value for is b, yes?
Yeah.
And the value they gave us is 1/3, but the real value we're looking at is 3. Is that 3 bigger than 1 or between 0 and 1? Bigger than 1, so it's telling us it's going to be a horizontal stretch of 3. Questions on this here? Oh, there was 2 more. Sorry. Let's look at these last 2. This one here, we don't have a value for k, but we do have a value for a, and it is 3. Do we do anything to that 3? No, it's vertical. We don't have to mess with it. It's only horizontal stretch or shrink that we've got to flip it. We also have a value for h. h's value is +1. The 3, now since it's positive, there is no reflection across the x-axis. But it does tell us that we have a vertical stretch of 3. H, left or right, tells us we're going to go right 1. Could be a vertical stretch of 3 and right 1. Questions on this here? We ready for the last one? When we look at this here, we do have a value for k. What's k's value? 2. Would it be +2 or -2? Positive, because it's +2. H would be -3. And we do have a value with a, it is negative. We could say -1, but it is negative. Now, since there's not a number with a, do we have a vertical stretch or shrink? No. But that negative does tell us that there is a reflection across the x-axis. The h value of 3 tells us we move left 3, and k tells us we move up 2. So it's a reflection across the x-axis, left 3 and up 2. Questions on this here? Okay. Now the only other thing we have left to do with 2.1 is to apply transformations to a function. And we're going to do those tomorrow. Now the assignment here, 3 through 11 odd, 17 through 21 odd, 27 through 29, 31, and 33. The only thing 31 and 33 are going to be our transformations, applying those there. We will be doing those tomorrow, so if you want to start on this, you can go on and start. We've done those before, but if you want to wait till after tomorrow to start those, that's fine too. So 3 through 11 odd, 17 through 21 odd, 27 through 29 all, 31 and 33. And that's it.